Hi guys, welcome to my first networking video in Excel. What I wanted to do here was just to explain where we get these slightly weird numbers from, and in IP addressing version 4, which is the one that I'm talking about here, so Internet Protocol version 4, we have what's called 32-bit addressing. Okay, and here you will see the actual bits themselves, which of course are ones or zeros, and the final address appears down here, and that is the 4 octet, an octet being 8 bits. That is the 4 octet address, which we are often very familiar with. Something else to note then with Internet Protocol version 4 is that if I do 2 to the power of 32, such as that there, 2 to the power of 32, I get this number here, which is 4,294,967,296. And translate that into plain English, so put in your commas, okay, that is 4,294,967,296 possible addresses. Oops, little typo there, just correct that. And that is how many possible addresses were conceived of way back in about 1972 by Vint Cerf and Bob Kahn. Of course, at that time, computers on the planet Earth numbered probably hundreds, maybe thousands, and even if they were all connected together, this seemed, I'm sure, like a pretty serious number and probably quite a sort of sci-fi number. We have actually got pretty much that number of machines on the planet now, and it's rapidly increasing, and that's why we need IP version 6, but that's a different story. What my spreadsheet does is we have the 1, 2, 3 and 4 octets of this address, which you see down here there, 1, 2, 3, 4, separated by the decimal points. That's just the convention. And here in decimal is the number of these added together. I won't show you the calculation. Well, okay, there it is. It's a little bit scary, but it's actually very simple. And so here, with all my octets filled with ones, I've got 255, 255, 255, 255. So that's the absolute maximum. If I change this to 0, hopefully that goes to 0, and I'll copy and paste. And there, of course, is your minimum 0 address, and that's written there. So this is basically how they are calculated. Now, I was thinking of my favorite IP address, and I've just ready-made some here. One of the ones that we use a lot at home, and in your house, no doubt, is the 192.168 address. So this is actually what it looks like in bits. Okay, 192.168, and then depending on your network number, sometimes your router is set to, whoops, not 2 there, to 1, and 1, that's a common address, 192.168.1.1, and that is the address usually of your router device in your house. Sometimes, like Virgin have with their high-speed broadband, their router has come defaulted to 0, which was annoying because then I had to change a lot of the static IP addresses in my house, but we can deal with that. So that's a common address. Out of interest, that's called a Class C IP address. Other common ones, which are used on local area networks, are the ones beginning with 10. These are called Class A addresses, so I'll change that there. Class A IP address, and they start with 10. And then all of these digits here represent the computers in the network. And so if I put a 1 in there, okay, that would be the address of one of the machines on the 10-dot network, okay. You might have noticed, even though I haven't really explained it that clearly in this video, that's deliberate, that if I have a class A address and that octet sets the number there, I've got 3 octets to play with here, which can actually be the addresses of different computers. So that's interesting. However, if I go back to this address, which is a class C address, such as this, and I think I'll go Virgin on this one and do that, okay. All of these octets here are actually called my network number, and I've only got this lowly number, this single octet here, to play with for the actual addresses of the machines. Okay, let's say that that was the router, then therefore this, this one, number 2, could be the first PC or laptop on the network, and then that would be the third one maybe, and I can start whacking these numbers up now. I'm going to skip a few now. That takes me to 7 computers, 15 computers addressable there. What happens if it's 14? Easy, just put a 0 in there, okay? This is just working with binary numbers here. 31, 63, probably haven't got 63 devices in your house. 127, getting a little bit Internet of Things and a bit big scale here. And finally, 255. Actually, in reality, you wouldn't address 255 devices in your house, including your router, because 255 is what's called a broadcast address. So actually, the top machine you could address would be that. And all the operating system is doing is basically processing these bits here for this 32-bit addressing scheme, which is Internet Protocol version 4. You've been with us for nearly 50 years. You've served us well. We are running out of room, but we salute you, IP version 4. Thank you for watching, and I'll see you next time.